Hello everyone, welcome to Virtual Labs. Today we will discuss Digital Electronics Lab designed by IIT Roorkee. So just click on Digital Electronics Lab, and in today's tutorial we will discuss the implementation of 1 raised to 4 demultiplexer using logic gates. So in previous lecture we have already covered 4 raised to 1 multiplexer. Today we will cover 1 raised to 4 demultiplexer. So demultiplexer is just the reverse of multiplexer. There is only one input and four outputs. Okay, in case of multiplexer, in 4 is to 1 multiplexer, there are four inputs and one output. So just the reverse in the case of demultiplexer. So for theory portion, just click on theory, and in the theory part of 1 raised to 4 demultiplexer, we will classify demultiplexer as 1 raised to 2, 1 raised to 4, 1 raised to 8, 1 raised to 16, and depend on the number of select lines that, as we have discussed in case of multiplexer. So this is the block diagram of 1 raised to 4 demultiplexer. Two select lines A, B, and the input that will appear at output A, B, C, D. It all depends on the combination of A and B. So if S1 is 0, S0 is 0, means for 0, 0, Y0 will be high. So input will be available at Y0. So Y0 is A, Y1 is B, Y2 is C, and Y3 is D. Okay, so A, B. So if A equal to 0, B equal to 1, F, that input will be available at Y1. For 1 0 it will be available at Y2, and for 1 1 it will be available at point Y3. Okay, so we can see or we can understand the working of demultiplexer, the truth table, the logic diagram of demultiplexer with the help of this diagram also. So there are two select lines A, B. These values 0 0 0 1 1 0 1 1, they will decide the input that will be which uh, output should be connected to the particular X. Okay, so now we will simulate the demultiplexer. So for this, click on simulation. So after clicking on this simulation part, just click on 1 raised to 4 demultiplexer. So this is the circuit diagram of demultiplexer. We can find out the expression for output with the help of this truth table. So output D naught equal to S naught bar, or we can say B bar A bar into X. So that D naught equal to A bar B bar into X. D1 equal to A bar B into X. D2 equal to AB bar into X. D3 equal to AB into X. Okay, so we can implement these output expressions of D0, D1, D2, D3 with the help of this circuit diagram, with the help of these basic ICs, AND gate and inverter. So here we are using two NAND gates, a 4 input NAND gate and one inverter IC to implement 1 raised to 4 demultiplexer. So there is a list of instructions which we have to follow for the simulation of this demultiplexer. So first we have to apply, or we have to provide power supply, that is +5 volt, to the pin number 14 of all ICs. Okay, so first click on this power supply. Now this is 1, so this is the symbolic representation of on state, and this one is for off state. Okay, now there are two select lines, select line B, select line C. This is 1, this is 0, this is 1, this one is 0. Okay, This switch is for data, that 0, this one is a 1, and this is for 0. Okay, there are 4 outputs, y0, y1, y2, y3, through which we can verify, or we can select a proper value of input, that is D, with the help of these two select lines. So if my select line is 0 0 and my data is 0, okay, so add this value to your truth table, you will get D at y0. Okay, so this is my output. For 0 0, D will be available at y0. The value of D is 0, so your LED at y0 is off. Now click on D. Now your D input is 1 and your output LED is also glowing. So you are getting your input, that is D, at 0 0, at 0 0 select line at the output. Okay, now my select line is like this. So add this. Now you will get your input D at y2. So your y2 LED will glowing, uh, will be red. Now you are getting your input D at terminal y2. Now change the value of select line to 0 1. So now you are getting your input D at y1. So your y1 LED is now on and it is glowing. And the last condition is 1 1. Add this value to your truth table. Now your data D is available at output y3. So LED 4 is now glowing. So this is all about the simulation implementation of 1:4 demux with the help of NAND gate and inverter. The basic difference between multiplexer and demultiplexer is the number of inputs and number of outputs. So in the case of 4:1 mux, 4 inputs, 1 output, but in the case of 1:4 demux, 1 input, 4 outputs. We can calculate the expression for output by simply solving the truth table of any particular design. So this is all about the working of a demultiplexer. Thanks for watching this lecture. Thank you.